Naji here. Welcome to my YouTube channel. In this video, we are going to discuss about simple linear regression. Okay. First, we can talk about linear regression. Okay. So first, I will go through the definitions. Then we can discuss more about it. Okay. So linear regression, we can say that it's a statistical way of measuring relationship between one or more independent variable versus one dependent variable. Okay, it's attempt to find a relationship between variables by finding the best fit line. Okay, so this is the definition for linear regression. So here we can see a couple of things, right? One is the first statement, it says that it is the way of measuring relationship between one or more independent variable versus one dependent variable. Okay, so we can talk about what is meant by independent variable and what is meant by dependent variable. So consider this example. Okay, so this is a data set, and in this data set we can see car name, year, kilometer, fuel type, and seller data, transmission, owner, and the selling price. So these are the features for this data set. So our goal is we need to predict the selling price based on these features. Okay, so when we see the features from A to G, okay, using these features A to G, we need to predict the value of the selling price of the car, that is the H. Okay, so the features from A to G, which is called the independent features. Okay, and using these independent features, we need to predict the value that is called the dependent feature. So the H column is called the dependent features. So in general, in a regression type models, we will have one or more independent variable and we will have only one dependent variable. That is, in this case, it is selling price. Okay. So I hope the difference between independent variable and the dependent variable is clear. Now, the next statement is, it is trying to find a relationship between these things. Okay, so this will be clear in our when we go through the next slide. Okay. Okay. Now, simple linear regression. So in a simple linear regression, it is very simple, right? So it has a one independent variable and one dependent variable. So in this slide, we have seen we will have like maybe 1, 2, 3, 4, 5, 6 or 7 independent variable, right? But in case of simple linear regression, we will have only one independent variable and one dependent variable. For example, consider a data set between years of experience versus salary. Okay, and consider another example, area of a house and the house price. So these are the few examples with respect to linear regression. Okay, so in a linear regression, we are actually trying to figure out, or we are trying to check the linear relationship between these two variables. That means the independent variable and that one dependent variable. Okay, and the strength of the relationship can be measured using the correlation coefficient. Okay, so how strong is the relationship, that we can figure out using the correlation coefficient. So I will explain what is correlation coefficient, all those things. Okay, and if we are considered like if we have a data set, okay, with one independent variable and one dependent variable, we got a data set. So initially we will think that okay, we can proceed with a simple linear regression. Okay, it is not the case. So first we need to see what is the relationship between this independent variable and the dependent variable. Okay, if the relationship is only linear, okay, then only we can proceed with the simple linear regression. Otherwise we cannot proceed with the simple linear regression. So this is a key thing. Okay, so by seeing one independent variable, one dependent variable, we cannot directly go with simple linear regression. First we need to see what is the relationship between this independent variable and this dependent variable. If that is a linear relationship, then only we can proceed with that. Okay, and so once that is done, okay, so once we figure out, okay, so we are going to do with so once we figure out there is a linear relationship, then we can proceed with the linear regression model. So the model, what the model is trying to achieve, the model is trying to achieve or trying to figure out or trying to find out the best line, best fit line for the data points. Okay. For example, if this is the data, so this is a data set, or maybe this is a scatter plot diagram with years of experience and the salary versus salary, then this line will be the best fit line, we can say, because this is almost going through all the data points, right? Or the difference, the distance from this line to this data point is very less. Okay, we can discuss more about how we will find out the best fit line, but this is in short, this is best fit line. Okay, so this is the goal of simple linear regression model. It will trying to find out the best fit line. Okay, now we can see what is a correlation coefficient and what is its formula, all those things. And its formula says correlation coefficient is covariance of xy divided by standard deviations of x and standard deviations of y. Okay, so I have already done videos with standard deviations and covariance. I will attach with this video, but in a simple term it is covariance of xy divided by standard deviations of x and the standard deviations of y. So we cannot do it manually, so we have a Python support for that. Python, there are different packages that support through which like we can easily figure out the correlation coefficient. Okay, and it's the correlation coefficient value is varies from -1 to +1. Okay, and if the coefficient is 0, that means there is no relationship, so we cannot proceed with the simple linear regression. Okay, and if the value is less than 0, okay, that means if one variable is increases, the other variable is decreases. Okay, so that is what is meant by if r is less than 0. If r is greater than 0, so both variables, if one variable is increasing, the other variable is also increases. Okay, so so that is the significance of correlation coefficients. By using this, we will get a rough idea the how strong is the variables and if they have like a linearly related, all those things. Okay, now I will show you a Python program through which we will trying to figure out this correlation. Okay, so here I have a notebook that is open. Okay, so let me give the permissions here. Let me give the permissions. Okay, so the execution is in progress. Okay, it is trying to mount the data. Okay, so mounting is done. So I have a data file or the CSV file in my drive. So this is the path. Now we can use the pandas for this one. So we can import. Okay, so this is my panda and I can read using the panda. It's a CSV file. I can mention the path. Okay, so we can show you df.head. Okay, here we can see we have two variables. One is years of experience and the salary. So the years of experience, we can say it is an independent variable and salary is a dependent variable. Okay, now we can see if there is any correlation between these two variables or these two features. So it's very easy. We can type df.core. So here we can see the relationship. We can see that okay, the years of experience and salary, it has a strong relation, that is it has a relation of 0.97, almost close to 100% relation between, almost 100% relation between years of experience and the salary, and which is positive. That means when years of experience increases, salary is also increases. Okay, so that is true, right? So in another thing we can see, we can look into Seaborn. can check the SNS here. Okay, so we can do a scatter plot which will give us a visual indication of this one. Here we can do a scatter plot. Can do a data SDF. Any x-axis I can give years of experience. And in y-axis I can mention salary. Okay, so here we can see there is a linear relationship. Okay, so when years of experience increases, salaries also increases, right? So if a person who is who has got like 10 years experience, he got more than 120k of salary here. Okay, and what our algorithm is trying to do, our algorithm is trying to figure out the best fit line for this one. I'm trying to plot this. Okay, so our algorithm is trying to find out a best fit line that is goes through most of the points, something like this. Okay, so that is what algorithm is trying to I'm sorry, our algorithm is trying to find out the best fit line that go through most of these points. Okay, so now we can see one more plot. We can do a heat map that will give us the how strong these are, the correlation is, and I can mention annotate is equal to true for annotation. So these kind of plots will really help us to visually figure out what is happening with the data. So here also we can see the relationship. It is very strong, 0.98, and this is 0.98. Okay, so we are good. Now maybe I will show you like one non-linear example. Okay, so how a non-linear data will look like. Actually, I tried to figure out. I tried to search for some data set, but I didn't get that. So I will create it manually, programmatically. I mean. Dot pyplot as PLT. Okay, here I can create few x points and few y points. Then we can try to plot that. So here we have x. I can take np dot random dot rand n. Okay, this can be one. I'm quickly writing this. You can take a uniform. Here I can check x, then this can be x star, can be x. Okay, I'm missing one bracket here. This will be here. Okay, so let me execute this, and we need y also. So y will be selecting only the so we are randomly generating few numbers. Now we can try to plot this. Okay, I can do a scatter plot, PLT dot. We can do a scatter plot. Here we can select x, and also we can do a y. PLT dot show. I just want to show how a nonlinear data will look like. Okay, so it will be like more clear. Okay, see, So this is a non-linear data. So here we cannot able to linearly separate x and y because it is scattered across data points. Here we cannot say that when x is increases, y is also increases, or x is decreases, y is also decreases. We cannot say we cannot say something like that. So this kind of a data set we may not able to solve using simple linear regression. Okay. So that is all about in this video. In our coming video, we can discuss more about simple linear regression, like how can we find out the best fit line and what are the possible methods and all those things we can discuss. Okay. So please do like and subscribe. Have a nice day. Bye bye.